In 1997, hidden Cold War microphones picked up a deep-sea sound louder than a blue whale, logged across oceans impossible to explain and heard only once. Scientists called it the bloop. This shock was just one of 6 mysterious ocean sounds that would terrify even the experts, exposing how little we truly know about Earth's last frontier. What happened next would force marine science to confront the unknown. In 1991, the world's oceans were already wired for secrets. For decades, the United States Navy had overseen a vast web of underwater microphones, hydrophones, strung across the seafloor. These arrays, originally built under the Sound Surveillance System, or SOSUS, were designed to catch the faint signatures of Soviet submarines moving through the deep. The technology relied on a natural phenomenon known as the deep sound channel, a layer of water where temperature and pressure combine to carry low-frequency sounds for thousands of miles. A single noise, if loud enough, could ripple from Antarctica to the equator, unbroken. With the Cold War's end, the Navy's priorities shifted. In a quiet handoff, the National Oceanic and Atmospheric Administration, NOAA, gained access to this underwater network. What had been a classified military asset became a scientific instrument overnight. NOAA's Pacific Marine Environmental Laboratory, or PMEL, began using the arrays to listen not for enemy vessels but for the ocean itself, whale songs, volcanic eruptions, earthquakes, and anything else the deep might reveal. These hydrophone arrays, stretching for hundreds of miles and anchored in remote waters, offered scientists a global ear, one capable of detecting the faintest tremor or the loudest crash. For the first time, researchers could monitor the ocean's hidden soundscape in real time across entire hemispheres. The data began to pour in, and with it came a new set of mysteries. The ocean, it turned out, was far from silent. Unexpected signals, some subtle, others overwhelming, started appearing in the records. Some would defy explanation for years, challenging even the most seasoned oceanographers. On July 25, 1997, a wave of confusion swept through NOAA's Pacific Marine Environmental Laboratory. Hydrophones anchored more than 3,100 miles apart, scattered across the ocean, all registered the same event. A sound so powerful it crossed an entire hemisphere. The recording lasted just over a minute. What set it apart wasn't just the reach, but the raw force. Several times louder than a blue whale, the loudest known animal on Earth. The signal began low and then shot upward in frequency, as if something immense had stirred in the deep and then vanished. Here's the strange part. The sound signature didn't match any known machinery or geological event. On the spectrogram, it looked eerily biological, like the call of a living thing, but on a scale no one had ever seen. If it were an animal, it would dwarf anything ever discovered. Christopher Fox, an oceanographer at NOAA, reviewed the data and dismissed the usual suspects. Not a submarine, not a bomb, not an earthquake. Field notes from that day describe a scramble among monitoring teams, urgent messages racing between stations as they tried to confirm what they were hearing. The event was named the bloop, a label that did nothing to explain its source. Scientists could triangulate its origin to a patch of ocean west of South America, near the Antarctic Circle, but that only deepened the mystery. No similar sound had ever been recorded, and after 1997, it was never heard again. The bloop's magnitude and fleeting appearance left researchers unsettled, a reminder that the ocean's depths still hold secrets beyond our reach. August 1991 brought an entirely different kind of puzzle to the desks of NOAA's Pacific Marine Environmental Laboratory. As the hydrophone network scanned the Pacific, analysts noticed a recurring pattern, a series of sounds rising from low to high frequency, repeating in long, ghostly trains. Each upsweep lasted only a few seconds, but the sequence would continue for hours, sometimes days, echoing across the ocean basin. When played back, the sound resembled the distant wail of an ambulance or a mournful howl lost in vast, empty water. Scientists named it upsweep. Unlike the bloop, which appeared and vanished in a single season, upsweep never truly went away. The signal's intensity would surge each spring and autumn, then fade, only to return the following year. Hundreds of these events were cataloged annually, their origins traced to a remote stretch of the Pacific, halfway between Australia and South America. The sheer scale was staggering. Upsweep could be heard across the entire ocean, its reach undiminished by distance or time. PML teams spent years searching for answers, launching expeditions and deploying specialized instruments to pinpoint the source. The leading theory pointed to volcanic activity, perhaps hot magma meeting cold seawater in some unseen undersea arc. Yet no expedition ever caught upsweep in the act. 30 years later, the sound persists. Its true cause still out of reach. For scientists, upsweep is a reminder that the ocean's most persistent mysteries are often the ones that refuse to be solved. March 1st, 1999. Analysts at NOAA's Pacific Marine Environmental Laboratory logged a sound unlike any in their archive. The event lasted about 15 seconds. Short but powerful enough to register across the entire Pacific. The profile was strange, a low, drawn-out moan that some compared to a distant coo or the whine of wind through a steel tunnel. The team named it Julia, a nod to a researcher's family member, though the reason is already lost to memory. Triangulation placed Julia's source somewhere between the Bransfield Strait and Cape Adare, deep in Antarctic waters. The leading theory pointed to a massive iceberg grinding to a halt against the ocean floor, but the singularity of the event left room for doubt. No other sound with Julia's signature has ever been recorded. For scientists, it was a reminder that the ocean can produce one-off events, rare, fleeting, and never repeated. Just 2 years earlier, hydrophones picked up something at the opposite end of the spectrum. On May 19, 1997, a slow, grinding noise began in the equatorial Pacific and dropped steadily in pitch for 7 minutes. This event, called slowdown, seemed to unfold in real time, a drawn-out descent, as if some enormous force was losing momentum. Analysts traced the source to Antarctic waters again, likely another iceberg dragging across the seafloor. Unlike Julia, slowdown has been heard again, though never on a predictable schedule. Each appearance is a reminder that beneath the surface, the ocean's hidden processes continue. Sometimes sudden and singular, sometimes slow and relentless. The variety in these anomalies challenged every assumption about what could be expected from the deep, leaving researchers to wonder what else might be undetected in the noise. March 5th, 1997. In the hydrophone logs, a technician scrawled a note, metallic like rails grinding. That morning, the network picked up a steady, low-frequency hum near Antarctica's Ross Sea. The sound pulsed with the resonance of train wheels on distant tracks. Analysts dubbed it train. Unlike the bloop or upsweep, train's signal was faint at the edges. Only a handful of sensors caught it, and the pattern lacked the breadth needed for precise triangulation. The best guess, a massive iceberg dragging its keel across the ocean floor, vibrations ringing through the ice and water. But the evidence was incomplete. The logs show repeated attempts to cross-check bearings, each ending with a question mark. No official spectrogram, no pinpointed coordinates, just a metallic echo fading into static. Then came July 7, 1997. A single hydrophone at 8 degrees north, 110 degrees west, caught a narrow-band, high-pitched tone, sharp and uncanny. The team called it whistle. It lasted less than half a minute, never repeated on any other sensor. Without multiple detections, triangulation was impossible. The source remains a blank spot on every map. Internal emails from that day capture a rare sense of defeat. No way to classify, no way to locate. Train and whistle expose the network's blind spots. Even with an ocean wired for listening, some signals slip through, out of reach, out of explanation. For every sound that could be traced to ice or volcanoes, there were others that left only questions. The scientists at NOAA's Pacific Marine Environmental Laboratory gathered around their screens, replaying each unexplained recording, aware that their network, spanning thousands of miles, still missed entire regions of the deep. The realization settled in. Even with the world's most advanced listening system, vast stretches of ocean remain silent. Not because nothing happened there, but because no one was listening. Official estimates suggest more than 80% of the ocean is unmapped, unobserved, and unexplored. Some outreach materials go further, repeating the claim that 95% of the ocean remains unknown. But here's what truly stuns scientists. Every unexplained sound is a reminder that the ocean is still a frontier, and most of its secrets have never been witnessed, let alone understood. The gaps in coverage are not just technical, they are a measure of how much remains hidden. For the PML teams, each mystery was a signal from the darkness, proof that the deep sea is not just unexplored, but possibly unknowable. 95% of Earth's oceans remain unexplored, a statistic that frames every mystery uncovered by NOAA's hydrophone arrays since 1991. The bloop, louder than any known animal, was captured across 3,100 miles of ocean in 1997. Upsweep has echoed for over 3 decades, while Julia and Slowdown appeared and vanished, their origins still debated. Train and Whistle pushed the limits of technology, with Whistle's true source remaining unconfirmed despite repeated detection. NOAA's later analysis points to ice and volcanic activity as likely causes, but some signals defy full explanation, even with today's advanced tools. These events force scientists to confront the vast unknown of the deep sea. The fact remains, every new sound reveals how little we truly understand about our planet. As hydrophones continue to listen, the ocean's most profound secrets still wait in the darkness, documented but not yet understood.